Hello students, in this video we will be learning about corrosion. It's a very common topic which we have already studied in class 12th and it is a quite wide also, so I have divided the entire chapter into 4 parts, and in this video we will be studying the first part, in which we'll study about the corrosion, what is corrosion, the definition, then why it is needed to study corrosion, then what are their types, and in this types one type of corrosion method, that is oxidation, we are going to learn. So let us start with the definition. As you can see the picture, even a layman can tell you that this happen in metal because of corrosion. Now why this corrosion take place? So you know that most of the metal, they exist in their oxides, hydroxides, sulfides, chlorides, carbonates, or and silicates form, which we also called as ores or minerals. Now this minerals ore, when go for the metal extraction, which we also called as metallurgy, to convert into pure metal, then a large amount of energy is needed, and it is also known that the metallic or the mineral ore form of the metal is more thermodynamically stable in compared to the pure form of the metal. So what happens, although by the process of metallurgy we convert this ore into pure metal, but this pure metal will always want to get converted back to the more stable form, that is their original form, or that is also known as minerals. So what will happen, as soon as it comes under certain environmental conditions, this metal will start converting into their mineral form. So with this process, by the process of oxidation. So how, and you know well that always the thing exists when they are in more stable form. So we are in this state, which is the more stable form? The more stable form is the ore form or the mineral form of the metal. So this metal always want to get back into their original state, which is considered to be the more thermodynamically stable. Or you can also understand this in other way, that you know, when this is suppose the ground state of the metal, when you apply certain energy, then it goes to the excited state. As we have already know that whenever it go to the excited state, what it will try to do, it will try to come back to the ground state. So while coming back to the ground state, there will be a release of certain energy, and this process occur during the process of oxidation. So we can define this, even metal from their high state going to their lower energy state, then the metal will be more stable when they are in their ground state or the lower energy level state. So the definition which is given for corrosion is that it is a process of gradual decay or deterioration. What it is written over here, the gradual, it doesn't happen in a day, it is a slow process or a gradual decay or deterioration, or what you can say it, the eating of metal from its surface by the unwanted chemical or electrochemical attack by its surroundings environment, and it is called as corrosion. So rusting of iron, you can see that is the example of corrosion. The copper vessels become green, that is also the example of corrosion. Now why it is kept in your syllabus, why it is important to study the corrosion? Then it is a data which is available worldwide, that corrosion is a very dangerous process and it involves a huge amount of cost. Because of corrosion, the metallic property like conductivity, malleability, ductility are lost, and because of this you may see a sudden collapses of buildings and bridges. The pipelines can break, chemical plants can leak, even you can see if there is a corrosion in the pipes of your bathroom, then your bathroom get flooded. Then if the corrosion happens in the electrical contacts, and it can cause fire also, and the medical implant may lead to blood poisoning. When we have some implants that is also made up of metals, and if they fail, if they corrode, then it leads to blood poisoning, which can lead ultimate death of a person. So it was observed that the World Corrosion Organization estimates that the global cost of corrosion is about $2.5 trillion annually, and that a large portion of this, as much as 25%, could be eliminated by applying a simple, well understood prevention techniques. So this is why you are studying this. If you know the reason why the corrosion is happening, you can minimize the rate of corrosion. Corrosion cannot be stopped, it's a continuous process, but what we can do, we can minimize it. Always remember this. You cannot completely stop the rate of corrosion, you can only minimize. So that is why it is kept in your syllabus, and it is not necessary that only one branch should know about this. If they are from civil or they are from mechanical, then they would study the corrosion. This is for all the engineering branches, because you all deal with the appliances made up of metals. So you should know what, why and when and how and why this corrosion happens. Now let us study the types. So basically the whole corrosion phenomena is divided into two types, that is chemical or dry corrosion and electrochemical, or it is also known as wet corrosion. In this particular video we will be studying about only chemical, or that is dry corrosion. Now dry corrosion basically happens due to the direct chemical action of atmospheric gases like your oxygen, halogens, sulfur dioxide, nitrogen, or anhydrous inorganic liquids with the metal surface. So therefore it has been divided into three subcategories. The first, when it happens due to the presence of oxygen, then it is known as oxidation corrosion. And then the attack of the other gases like H2S, SO2, and then we have liquid metal corrosion phenomena. So first we will start with the oxidation corrosion. I think you all know what is oxidation. Oxidation is nothing but a process of release of electrons from the metal. Now this carried out by the direct action of oxygen at very low or high temperature and in the absence of moisture. That is why it is also known as dry corrosion. Always remember that whenever oxidation corrosion take place, it take place in the absence of moisture and in the presence of oxygen. So basically alkali metals and alkaline earth metals are rapidly oxidized at low temperatures, and at high temperatures all metal oxidize. So what happens during oxidation? Metal will release the electrons, and these electrons will be absorbed by the oxygen. And then for a complete reaction there should be oxidation and reduction both, and that is why every reaction is known as redox reaction, because a reaction cannot be completed if oxidation and reduction doesn't happen. If the release of electrons take place, then it is also important these electrons will be absorbed by some other moiety, and here this is oxygen. So overall reaction is if metal comes in the contact with the oxygen, it forms metal oxide. So, so what happened initially, if you have a surface of any metal, the corrosion will start with the surface of the metal, and when it attack the surface of the metal, then oxides of this case form a barrier which restrict further oxidation. The extent of corrosion depends upon the nature of the metal oxide. So type of metal oxide layer formed on the surface of the metal will decide whether this corrosion will further continue or whether it will stop at once. So on that basis, we have divided this metal oxide into four parts. The first metal oxide layer is known as stable. So and it is also known as a protective layers. Why it is called as a protective layer? It is called as a protective layer that because if the layer which it prevents further corrosion. Once it forms a layer, it doesn't allow the other oxygen to penetrate inside the metal, and thus once a layer is formed, the rest of the metal or the base metal get protected. Yeah, see this is suppose metal aluminium, right? And when it comes into the contact of the oxygen, what will form? Aluminium oxide. So this once the layer is this, we have always previously we said that the attack will take on place on the surface. So when the surface will come into the contact of the oxygen, this layer is formed, and this layer is stable and and non-porous. Remember, non-porous means there it will not allow the oxygen to move inside it. Once the layer is formed, corrosion will stop here only. There will be no further corrosion take place. So that is why it is known as stable metal oxide layer. The second type is known as unstable. Unstable, the example is common example is your gold, silver and platinum. Generally it is said that gold, silver and platinum are the nut metals, so it doesn't corrode. But basically what process take place here? Metals like your silver or gold or platinum, silver if it is not pure 100%, then it also get very easily corroded. But we'll take the example of gold and platinum. I think everybody wears this gold and platinum. If corrosion happens in these two, then the ornament which you wear will vanish within 1 or 2 months, right? So what happened, and it doesn't mean that it doesn't go for oxidation. It does go for oxidation. The metal will come in contact with oxygen, they form a layer, but this layer is very unstable. As soon as this layer is formed, the decomposition will take place, and then that converts back this layer into metal and oxidize. So soon as the layer is formed, back converted into metal and oxygen. So you cannot see, this is a very fast process. As soon oxygen attack to the metal, it form metal oxide, and again this metal oxide get converted or decomposed into metal and oxygen. Therefore your gold, silver and platinum get protected. Now there is one question always asked in the examination, give the reason why gold and platinum doesn't corrode. So while writing it's a noble metal, you have to mention this diagram ki although the oxidation reaction take place and the metal oxide layer form during the attack of oxygen in gold and silver and platinum, the metal oxide layer is highly unstable, so it easily decomposed to metal and oxygen. So this process is very fast, and that is the reason why platinum and gold doesn't corrode, right? So this is for one is stable, this is unstable. Then next is the next type of layer is metal oxide layer is volatile. Volatile, you all know what is the meaning of volatile. Volatile means which vaporizes. So there are certain metals like molybdenum, when they come into the contact of metal, again what will happen? It will again form a metal oxide layer, but the metal oxide layer which they form is volatile in nature, right? That means it evaporates with the atmospheric conditions, and since this layer get evaporates, and this again the base metal is remains. Further, this base metal will have a fresh surface layer to get get contacted with oxygen, and again the volatile layer will form, and slowly the whole metal will disappear into the atmosphere. You can have the similar example of like camphor. If you place it in the presence of atmospheric oxygen, it evaporates easily. So similarly in this case also happens in the volatile metal oxide layer. Metal oxide layer which is formed is volatile in nature. As soon as it forms, it vaporizes to atmosphere. Then the metal having the another fresh surface, again the oxygen will attack on the surface, again it will vaporize. So slowly the whole metal get decomposed. And now the fourth type is your porous. So this is a very good example where we can see in the first picture we have seen so many items get corroded. The best example can be the rusting of the iron. So what happens when metal come into the contact with oxygen? They form the metal oxide layer, but this metal oxide layer is porous in nature. Porous in the previous, like in this case we have non-porous or stable, right? In this case it is non-porous and unstable. So what happened, as soon as metal come into the contact, this for the uppermost layer get corroded, and this also allows the oxygen to get enter into the pores, and then again the part of the metal gets slowly corroded, and this form gives you the rust. Now the third type is the corrosion due to the other gases. This type of corrosion is due to gases like other than oxygen, like your sulfur dioxide, carbon dioxide, chlorine, H2S, fluorine, etc. In this corrosion, the extent of corrosive effects depends mainly on the chemical affinity between the metal and the gas involved. Okay? The degree of attack depends upon the formation of protective or non-protective film on the metal surface, which is explained on the basis of Pilling-Bedworth rule. Now this is very important. What is Pilling-Bedworth rule? So this says that if the volume of the corrosion film form is more than the underlying metal, what they said, the volume of the corrosion film, right, form is more than the underlying metal, it is strongly adherent, non-porous, and does not allow the penetration of corrosive gases. The example is silver. When come into the contact with chlorine, it forms AgCl, a protective layer. No further corrosion will take place. This uppermost layer will protect the inner metal, and therefore you can see the aluminium, you can see it in the surface get a slight corroded, but as you soon just rub with a simple scrubber, or it shines again, but there will be no porous type of corrosion take place. So once the layer is formed, no further corrosion will take place. This is explained in this. And second, it says that if the volume of corrosion film is less than underlying metal, here what is then, it's more than, no corrosion will take place. But if it is less, the volume of the corrosion product which is formed is less, then the further corrosion will take place in the underlying metals. Like your simple example, steel. Okay, if they come into the contact with the H2S gas, then it forms ferrous sulfide and it is porous. That means the underlying metal will again attacked by this H2S gas unless the whole Fe or the steel get corroded. So this is how he explained कि on the basis of volume you can decide whether the corrosion will further take place or it will stop at one's place. So if volume is more, then it will protect it, and if the volume of the layer form is less, then the further corrosion will take place. Now the last is your liquid metal metal corrosion. This corrosion is due to the chemical action of flowing liquid metal at a high temperature on a solid metal or alloy, and the corrosion reaction involves either dissolution of solid metals by liquid metal or internal penetration of the liquid metal into the solid metal. Like example, like your coolant, which is a sodium metal, leads to corrosion of cadmium in nuclear reactors. So you can again explain this method by giving examples, but in journal the question is asked on the dry corrosion. Dry corrosion, the types of metal layers form when dry corrosion take place. Basically what is stable metal oxide layer, what is unstable, volatile or porous. So basically question is asked on these types of layer. And the next, what is wet corrosion or electrochemical corrosion, we will be studying in the second video or in the part 2. Hope you understood why corrosion is to be studied and what are the types. So here we have only discussed about oxidation corrosion or chemical corrosion. The electrochemical corrosion we will be discussing in the next video. Thank you.